I solve a trig equation that's got tangent in it? Well, it's very similar to what we do with sine and cosine. I'm seeing some kind of, something's being cubed, so I'm going to momentarily pretend I'm not worrying about tan. I'm going to say u equals tan x, just to get rid of that, get that out of the mix. So u equals 3u, or u cubed equals 3u. So, well, if it's a polynomial, I'm going to set it equal to 0. And then I see a greatest common factor of u, so I'm going to factor that out. So let's see, u squared minus 3. And then I get two choices. Where does u equal 0, or where does u squared minus 3 equals 0? And of course that becomes where does u equals plus or minus the square root of 3. Then we got to deal with the tangent. So doing that back substitution gives us this. So when is the tangent equal to 0? Well, if you think about the arctan function, because that's what we're really what you're doing, is you do the arctan of both sides, right? So you're really asking when is the tangent equal to 0? Well, if I think about the tangent graph, or you can even think about the arctan graph, I'm seeing when x equals 0, tangent equals 0. It's also true, now remember these are vertical asymptotes at pi over 2 and negative pi over 2. So it will be, so we got to think about where this repeats. Well, it repeats again at pi. So, because that's the period of the tangent graph, one thing. So we can say it's 0 plus pi k. That would be all solutions. I'll have to go back and look and see what they're looking for, but that's one set of solutions. Now then, where does the tangent equals root 3? Well, let's see, I got to draw a unit circle here because I never remember this. I do know the tangent's equal to, let's see, a positive number here and here in quadrant 1 and quadrant 3, and then that kind of shows up here too, right? In quadrant 1, tangent's positive, and quadrant, let's see, this would be quadrant 3, that's quadrant 2, right? Quadrant 3 is here, so it's positive. So that reference angle, I'm looking for when is that reference angle? Well, actually, I'm looking for what is that reference angle. So if that's the case, it's telling me the tangent is equal to root 3, opposite over adjacent, right? So root 3 over 1, which probably makes this 2. Which if this is, so what I'm thinking about, oh, okay, so this is going to be that root 3 over 2 is going to be 60 degrees. So pi over 3 is that first answer. Then to get all the way around to this one, isn't that reference angle also pi over 3? And it's just plus pi, because that's the period. So we can say plus pi k. And then when is the tangent equal to negative root 3? Well, that tangent's negative in quadrant 2 and quadrant 4, and it's still going to be the same thing though. The negative's coming from that negative 1 on the x-axis, so that reference angle is pi over 3 also. So 2 pi over 3 plus another pi k. So those are all the answers for this graph. I mean, for that equation, original equation. We could check this graphically. So we can see, I mean, here's the 0, and then add pi is there, and add another pi, and add one more pi, and that's that set of answers. Then let's see, then we had pi over 3 was my next answer, so pi over 3 plus 3 pi over 3 plus 3 more pi over 3 plus 3 more pi over 3. I could even subtract 3 pi over 3, and I get that answer right there. But of course I didn't label that. Then the other answer I got was 2 pi over 3. Well, 2 pi over 3 plus 3 pi over 3 plus another 3 pi over 3, or I even subtract 3 pi over 3 and get there. So there's the answers. And notice what I did to solve this graphically. I set both sides of the equations, the original equation, equal. Okay, so this is a nice way to check your work. If it's just a graphical solution, it's a way to solve it, but I really need you to be able to do this algebraically also. So I was looking at numbers 35, 30, and number 33 and 35, the same kind of questions where you just got to factor out a greatest common factor and solve it. 42 is a little different, where it's actually I'm going to get like a trinomial. If I say that u equals tan of w, I can replace everything and rewrite that as 1 minus 2u equals u squared. Then that, well, I see a quadratic equation. I'm going to set it equal to 0, so u squared plus 2u minus 1 equals 0. And then I got to try to solve this and factor this. And well, let's see. What'll multiply to give me -1? That'll add to give me 2? I don't think anything. So I'm just going to use a quadratic formula to solve this. Well, according to my calculator app, that's what the solution to this inequality, this quadratic equation is. So then we've got to find the. So we got to go back and do this back substitution, and I know the tangent of some angle has to equal -2.414, and the tangent of this angle also has to equal 0.414. So that I have no idea what that is in actuality, so I'm going to use a calculator and do the arctan of that answer. I'm also going to do the arctan of this answer. So that's what my calculator told me those two angles are. Now I got to think about all possible solutions. Well, I know for the first one, I know the tangent's negative. I'm talking about this negative here, right? I know that's the value, right? When is the tangent equal to -2.4 whatever? Well, the tangent's negative in quadrant 3 and in quadrant 4. I also know that reference angle is going to be, let's say, I got to think about what the arctan tells me. I know that the arctan graph looks something like this, and I know it's limited from -pi/2 to +pi/2 in the range. So that's telling me that so I know this angle here is out of the picture, right? I know this angle right here is not this angle, because for one thing, that's a positive angular rotation. So that's the angle that the calculator told me about, right? That's that negative angular rotation. That's telling me that's also the reference angle. So this angle and that angle are the same because of trig and also because of vertical angles. So this angle right here, that reference angle, is also 1.178. So if I had to find this angle, I'd have to take that away from pi. Unfortunately, I think we can just take this answer here and add pi to it, and won't that get me right back there? So if we say plus pi k, and then if I add another pi, that pulls me right back around there. So I think we're good with that. We don't have to think much more than that. And the same kind of thinking goes with this one, except we're going to be in quadrant 1 and quadrant 4, or quadrant 3. Here's the reference angle, so plus pi. So I think I'm going to say plus pi k, and that'll be all answers for that solution too. And we should graph it to look. So I graphed that equation and found these for solutions, and it does check. I'll leave it to you to do these calculations to figure out how are these 8s equal to those decimal values we got. I'll give you a hint. You're going to want to think about taking your number answer, and if we were going to convert that to degree form, we would take multiply that by 180 over pi. Well, just take that decimal number, divide it by pi, and you'll see a fraction. You'll see where the 1/8 is coming from, the -3/8 are coming from. Okay, so I hope that helps you answer those questions.